Okay, we're going to talk about reviewing the rules for finding discontinuities, holes, and asymptotes in a rational function. So here's an example of a rational function, y equals the quantity x plus 2 over the quantity x plus 2 times x minus 2, which we also could have written as x squared minus 4. If we saw it as x squared minus 4, the first step we would want to do is factor it, which is what I've done here. So the first thing I'm going to look for is any holes. Holes are found anywhere that there is a common factor in the numerator and the denominator. And I notice that I have x plus 2 in the numerator and x plus 2 in the denominator. So I'm going to set that common factor equal to 0 to find the x value of my hole. And then I'm going to look at what's left of the equation. Well, when I factor out those two like terms, I'm going to have 1 over the quantity x minus 2. So my graph of my original function and this new function, 1 over x minus 2, are going to look identical except at the place where I have my discontinuity, at the place where I have my hole. I have my hole when x equals negative 2. If I plug negative 2 into the bottom of this fraction, I get 1 over negative 4. So the coordinate pair that I have at my hole is negative 2 comma negative 1/4. If I want to find a vertical asymptote, I take whatever's left in my simplified fraction in the denominator and I set that denominator equal to 0. That gives me a vertical asymptote at x equals 2. I'm going to finally look for a horizontal asymptote. Now you're either going to have a horizontal asymptote or a slant asymptote. You're not going to have both. I'm going to look at what's left in my fraction. If the degree of the numerator is smaller than the highest degree in the denominator, you'll always have a horizontal asymptote of y equals 0. If the degree of the numerator and the degree of the denominator have the same value, like x squared over x squared minus 3, you look at the coefficient in front of those two same degree exponents and take that fraction as your horizontal asymptote. If the degree of the function in the numerator, the power is higher than the denominator, you're not going to have a horizontal asymptote. You'll have what's known as a slant asymptote. If the degree on top is 1 more than the bottom, you will find that slant asymptote by using long division. So in this case, I look at the degree in my numerator. Well, that's really x to the 0 power, and my degree in my denominator is x to the 1st power. So since the denominator is smaller than my numerator, my horizontal asymptote is at y equals 0, and there is no slant asymptote. Here's a different sort of an example. In this case, I look and the numerator is not factorable. I know that because there are no factors of 7 that are going to add up to 5, so I have to leave that trinomial alone. So there is no hole in this expression because there is no common factor. So the next thing I'm going to look for is the vertical asymptote. The vertical asymptote is found wherever the denominator is equal to 0. My denominator is x plus 1, so I have a vertical asymptote at x equals negative 1. And now I look, do I have a horizontal asymptote or a slant asymptote? I look at the degree of the equation. I have x to the 2nd power over x to the 1st power. That numerator has a higher power than the denominator, so there is no horizontal asymptote. Instead, I have a slant asymptote, and I find the slant asymptote by doing everyone's favorite long division. So I'm going to go back to my original problem, and I'm going to try and move this page up so I have a little more room. Maybe not. All right, we're going to go back to my original problem. X plus 1 is being divided into x squared plus 5x plus 7. And if we remember our long division correctly, this should be pretty easy to do. I'm going to take x times x gives me x squared, x times 1x gives me 1x. I'm then going to subtract all of this. Those will drop out. I'll get 4x plus 7. That means that this must be plus 4, because I'll get 4x plus 4, and what's left over is just a remainder, and it's inconsequential, so my slant asymptote is y equals x plus 4. Once again, hopefully you remembered how to find all your asymptotes.